Hi, my name's Victoria, and I'm a final year DPhil in the Robertson Group here in Oxford. Originally, I'm from Bradford, and I went to Bradford Girls Grammar School. I just picked A-levels of subjects that I liked, really. So I did maths, biology, chemistry, and geography. And out of all of those, chemistry was always my favourite one, so that's what I decided to apply to do at university. So I applied to Brasenose College in Oxford, and that's where I got in and did my undergrad. So the course is an MChem, which is a 4-year undergraduate course, and it has the usual mixture of labs, lectures, classes, that sort of thing. But it also leaves plenty of time for other things as well, so you can see like sports teams and balls and that kind of thing. But actually, the standout part of the Oxford undergraduate chemistry course is the Part 2 year. So that's the 4th year, and instead of having lectures and classes and stuff, instead you join a research group as a full-time member and you work on your own project. So this was my project about dual catalysis. So that means using combinations of catalysts to do really specific reactions. And I really enjoyed actually being able to use the theoretical knowledge that I'd gained during the first 3 years of my degree and applying them in a practical setting. And actually this was what made me decide that I wanted to do research at PhD level. So I decided that I would stay in Oxford, but that I wanted to change groups. So this is my current group, the Robertson Group. And I am paid to work in this group as a researcher. I get opportunities to travel, so I go to conferences, there are opportunities to go abroad, to work in industry, all of that kind of stuff. And we're also actively encouraged to develop skills outside of actually doing chemistry. So for example, I learnt to speak Spanish. But obviously the most important part of doing a PhD is your project and the research that you do. So I'm a natural product chemist, and what this means is that a useful chemical was discovered in a plant, and it's my job to make that from commercial chemicals, so from things that we can buy. And this idea of getting useful compounds from plants isn't a new idea. So you may have heard the ancient Greeks used to chew willow bark for the pain-relieving properties, and actually there's loads of other examples too. So my natural product is called viridiol, and it comes from this beautiful fungus. So they think that it may have some anti-cancer activity, but really we need more of this material in order to be able to test that. So the fundamental approach to a project like this is that you're starting with something very, very complex, and you need to break it down, take pieces off, in order to make it something simple that you know how to start with. So we take my natural product here, and I theoretically chop pieces off until I can start with some simple building blocks, and that makes accessing this much more straightforward theoretically. So this is an overall summary. It's called a retrosynthesis, and it shows us the overall plan of my project. But the really fundamental point is that I'm using both chemistry and biology because I'm using enzymes. And the key thing is that neither chemistry nor biology were able to provide us with enough viridiol for our purposes. Chemistry, we didn't have the tools to do all of the reactions. Biology couldn't produce enough. So in using both of them, I'm achieving what neither of them could do together. Thank you for listening, and check out the website if you want to find out more. Thank you.